Welcome to another episode of Translating Technobabble. My name is Gary Schultz. I'm the Vice President of Marketing and Sales here at Briebug. I'm actually sitting down today with Lucas Ruebelke. You've been working as a trusted advisor for lots of executives, engineering managers, being a trusted guide for them, over a decade now?
Yeah, over 10 years.
Google development expert in both Firebase and Angular technologies.
That's true.
And one of the things we wanted to sit down and talk about a topic that every executive, every engineering manager are dealing with every day. And that's this whole notion of speed or velocity,
yes.
Release.
Yes.
Let's get features out the door. Let's move things quick now.
Let's get it done.
And we want to translate this because I think there's a lot of misnomers as it relates to speed and what needs to be sacrificed. What does speed mean today in the enterprise?
Quality is really the accelerant to speed, because we have to be able to not only give a customer what they want once, twice, 10 times, 1,000 times, N times. We need to be able to predictably do that.
What I'm hearing you say is, in order to actually have speed, giving customers what they want at the velocity that more of what they want, you have to have quality built in.
Exactly. So that you can continue to give customers what they want. So the goal is speed, but not only to achieve speed, but to maintain speed through quality.
You have to have
and
quality,
by predictably and consistently putting things in the customer's hands. More importantly, is to do this without introducing unpredictability back in the system.
Right? Now we're back to quality.
How do we achieve it?
Yeah. What are we experiencing? How to do this the right way?
So with feedback loops, we validate our efforts with feedback loops. How do we qualify what we're building? Is
to get everybody around the table rowing the same direction.
Yeah, and more importantly, so we do a unit of work, and we need to validate it. We need to qualify it. And so, in terms of a feedback loop, putting it in front of a customer in the early stages of development and saying, does this work for you? Does this make sense? Do you like this? And then getting feedback, well, that's going to direct your efforts to keep building it. Now you know you're on the right track. Or more importantly,
developers' hearts are in it.
They're in it. It's been validated. Not only that, it's now your customers, because they know what's happening. They're on board. And equally profound is if you do something and they say, this doesn't make sense. Well, you found that out in, let's say, a day versus 5 months from now.
Right. We see this all the time.
You are essentially gaining speed in the sense of you are not wasting effort. So by concentrating your efforts on the things that matter,
value to the
that
customer.
Creates more value. It creates better acceleration. And so we ensure feedback loops. Again, we qualify our efforts by getting feedback as soon as possible. So in software, there's this concept of test-driven development. And in its kind of purest form, so the purist will say, you don't write any code until you have a test in place. So it's very much unit test driven. And philosophically, I agree with that in the sense of at every step of your software development lifecycle, you need to have test. But the difference is, at the onset of a project, there's a high level of variability.
Or a new feature to a platform.
Or new features is when you're starting something new, you have to be very honest with yourself and realize, start with a blank slate and realize we don't know anything. We have hypotheses, we have conjecture, but we don't know anything. And so you need to test your efforts. And so I believe in test at all levels of the software development lifecycle, but instead of starting with unit test, start with user test. And so you validate what you're doing through simply asking people, soliciting valuable feedback from your customer development partners or people that already are a fan of your product. Like, give them an opportunity to give them feedback. So not only, again, are your developers engaged, but you're pre-existing.
Because they know what they're working on matters.
Yeah, absolutely.
Right? So if I heard you right, at the early onset of new development, a test would be feedback loops, customer feedback loops. In that stage, are we putting unit tests in place?
No, I highly recommend not. The reason being is because if you don't know what you're building, then, or if you haven't validated what you're building is the right thing, then you need to have the emotional relationship that I'm going to throw this away. So when you're doing proof of concept work, which is very, very quick, it's an accelerated process of we're building this thing, but we're going to do a proof of concept in a day, 5 days, whatever, is that validate what you're building first is the right thing.
Before you put some overhead of unit testing and things like that. Because you're going to iterate, you might even throw it away, to your point. Got it, okay. So let's say then, with an eye on speed, getting the team around the table so we can move quick, don't put unit tests in place early. Let's say we get this first piece now. We got customers going, yeah, we'll pay for that. Best practice, what's next?
So it's very human-centric at the beginning, but then as you start to reach a high level of certainty of what you're building, and you have started to, you get these confirmation data points coming in, well, then you can start to shift your efforts into unit test, and end-to-end test, and integration test. And so I'm a huge proponent of unit test, end-to-end test, but it needs to be at the right place in the software development lifecycle. So once you have validated what you're building, then validate that what you're building is correct, and it's of high quality and sufficient quality. And so you start to see this spectrum of human testing, human validation, into technical validation, to ultimately, in kind of these maintenance cycles, that you have these automated continuous integration pipelines where they're always running these tests, they're always running these automated end-to-end tests, and that validation is always happening automatically in the background. And that's where you shift into.
Got it.
Is that from human, validated initially very quickly. And I think the other thing is, it's worth mentioning that a lot of times people, they do not write tests because the barrier to entry, it sometimes seems very high, or everything is still it's dynamic, it's in flux, and so they don't know. And so I think cognitively they realize it doesn't make sense to write test. And so what happens is they end up not writing test at all.
At all, which goes back to the first part of this conversation.
And so it's one, what is our relationship to speed? And more importantly, how are we qualifying it? In, I think, having the right feedback loops along that software development lifecycle, that's going to ensure that you're validating or you are qualifying speed at the correct way at every single level.
Even with our large enterprise customers, we're seeing this features that are released and they haven't been tested. So there's unpredictable user experience, lots of fires being put out. Developers staying up very late at night trying to fix this. We got the feature out. Speed, not really. We're going back and fixing all this. So we actually lose time. We lose our customers' hearts in this process, right?
And ultimately, you're not back where you started. You're worse than where you started.
Way worse, right? Because now we might have even lost trust. We might have lost users.
Exactly.
Right? Customers, valuable customers.
And the industry is full of these stories. I mean, you look at the healthcare.gov site. And I mean, there's just story after story of companies that have spent an insane amount of money to build something that nobody wanted. And they rushed it to market. Instead of qualifying what they were building on the onset, what ended up happening is they ended up wasting a ton of time, and really the net sum was negative in terms of their speed.
Right. So we know their mindset that you're recommending.
Yes.
And it's super clear to me.
It's very strategic.
It's strategic, and I understand the quality that's built in, and if we have quality, then we get speed, and what that means. But are there some really tactical things that we could give our listeners that they could go into their engineering teams with that mindset? Are there some technical things that we could leave them with?
The number one thing that when programming is having a rigorous commitment to software fundamentals. Let me give you 3 anti-patterns that I see a lot. And so I refer to this as the axis of evil.
That decrease quality.
Yes.
Slow speed down.
Yeah, well,
right? All that, yeah.
Yes. I mean, I'll get into, we'll talk about this.
Okay.
The first one is hidden state. Secondly is a single responsibility principle violation. And then thirdly, nested logic structures. And when you see these 3 anti-patterns in your code, then ultimately what happens is it's going to bring your code base to a screeching halt, which is the opposite of speed. Now, typically what happens is organizations, instead of addressing the core causal effects that cause this code base to get into this state, what they do is they just do a rewrite. Oh, well, we're on Angular, now we're going to do it in React. Or we're in React, now we're just going to do it in Angular. And so they'll just do a rewrite, and they won't address the fundamental problems that are causing this.
Not following coding best practices.
Not following fundamental principles that have been around for years.
Got it.
And so, as a manager, to your team, that when you see these patterns, ironically, they're the worst patterns that I can think of, but they're the easiest to fix. So if you have hidden state in a method, you simply extract that to a parameter that you pass into the method. If you're violating, the single responsibility principle, and by extension, the nested logic structure, all you do is you extract that into a smaller, single-purpose, standalone function. Very easy to do. You're not re-architecting everything. You're just saying, I'm moving this hidden state into a parameter. I'm taking this nested code, or I'm doing more than one thing in a function. I'm going to break these out into smaller, single-purpose functions.
Got it.
And what this allows you to do is, one, you reduce your side effects, your unpredictability, but it also allows you to write code that you can then test and reuse, because if something
others can
reuse, so they're not having to recreate it. So a nested logic structure. So imagine you have like a switch block, and you have all this code in here at every statement. Well, if it's nested in that switch block, first of all, it's really hard to test. More importantly, you cannot use that nested code anywhere else. And so I can't think of anything that's more inefficient than reduplicating efforts. And so you simply go through, you extract that out into a standalone function that you can reuse, and from there, now you have a bunch of single-purpose, fine-grained codes or fine-grained functions that, if possible, again, make it pure. And there's some very simple things that you can do like that makes your code easier to test and easier to reuse. And I'm going to say this emphatically. There is not enough time in the world for us to adequately test bad code.
Right.
And so when you cannot write good tests for bad code. We don't have enough time for that. And so again,
that's the takeaway
when
here.
Managers come and say, we don't have time to write tests, more often than not, when we go and look at their code, they're breaking the axis of evil, and maybe some other variations. But because there's not a commitment to these fundamental principles, there's nested state. They're breaking the single responsibility principle, nested logic structures, and it's impossible to test. And what happens is when you write good, clean code, you're actually writing less code that does more, therefore ensuring quality and speed.
Super insightful, right? So we've talked about changing mindset in terms of what it really means to talk about speed.
Yeah.
And inherently, there has to be quality built in.
Yep.
We've talked about specifically the mindset around outcome-driven development, getting feedback loops in place that empower the whole team, that ultimately create quality that's built in, how to sequence unit testing and the life cycle of how to build in your tests so that you have quality, so you can get the speed customers more of what they want. Super insightful.
Thank you.
We hope that you've gotten a lot of value from watching today. And Lucas, I want to thank you again.
Thank you so much.
Till next time.